Hello and welcome to our video tutorial. Today we'll be looking at Unit 5, Lesson 5, Translations in a Coordinate Plane. Please remember that translations involve moving an object, points that make up an object, around a coordinate grid by moving it up, down, left, or right. But it could also involve reflections like you saw in lesson number 4. So please be prepared to do translations and reflections as we continue here. Let's begin. Number 1, given triangle ABC, as you see right here in the graph, graph and label triangle A double prime, B double prime, C double prime after the sequence of transformations that consist of a reflection over the line y equals 2, followed by a translation of 5 units to the right and 3 units down. Okay, let's figure out what all this would look like. Well, I'm first going to find A prime, which is going to be the reflection about the y equals 2 line. So y equals 2, 1, 2, right there. Okay, so to reflect about that line basically means that A is going to be right there because it's right on the line, but B is going to be this far away. It's 4 units away, so it's going to be 4 units. Sorry, no, it's not. It's 6 units. 6 units away from y equals 2, so it's going to be 6 units above or right here. So this would be A prime right there. So you can see that's going to have the exact same x coordinate. So it's going to be negative, let's see, negative 9. Let me see here. What would that be? So negative 1, 2, 3, 4, 5, 6, 7. Sorry, negative 8. Negative 8. No, negative 7. Negative 7. And it's been moved up to, x equals 8. There we go. So, sorry. This one, A is going to be the exact same. So it's at negative 9, 2. It's going to stay at 9, 2. Okay. So I first want to find out what the reflection is going to look like, then we'll focus on the translation. So it's easy to do this if you do it one little step at a time. If you try to do too much at once, it becomes a little much. So to find the reflection of this point, okay, about that line, you can see that I'm going all the way up here. Sorry, that would be not A prime, but B prime. And it would be 6 units above that line. Okay, so that point would be still negative 7, but I'm going to add 12 to that, 6 and 6. So I'm going to add the 6 to there and then another 6 to there, and it gives me 12 above negative 4, which is 8. That point right there is negative 7, 8. Okay, and then C prime is going to take that point there, and that point is 4 units from the line of reflection. So we're going to move that 4 units above, right there. There's C prime. Right there. Okay, so here's our triangle. A prime, B prime, C prime. Okay, and now what we're going to do at this point, what we're going to do Sorry, let me just delete this real quick. What we're going to do is we're going to take and I'm going to take this and put it in a different color just to make it kind of stand out a little better. So my reflection, my reflection about the point, about the line, excuse me, y equals 2, takes this, reflects it over here to get that image. All right. Now we want to take that and we want to translate it 5 units to the right and 3 units down. So that would kind of look like this. We'd basically be taking this triangle and moving it 1, 2, 3, 4, 5, and then 1, 2 units down. And that's ultimately what we're going to do. We're going to take each of those points and do that. So I'm going to take each of those points and I'm going to go 5 units to the right, 1, 2, 3, 4, 5, and 2 units down. There's our C double prime right there. Okay, then I'm going to take this point and go 1, 2, 3, 4, 5, and 2 units down. There's my B double prime right there, right where C prime is. And then A is just going to be moving 1, 2, 3, 4, 5, and 2 units down, just like that. There's A double prime. Okay, and then we'll just go ahead and connect those. And you have your reflection about the line y equals 2, and you have your translation. So the orange triangle, that's the final not only reflected image but translated image as well. So this one here is the sort of the final one. Explain why A double prime, B double prime, C double prime must also be congruent to the original triangle. Well, since reflections and translations are rigid motions, putting them in a sequence is also a rigid motion, and rigid motions preserve shape and size. So the two triangles must have the same lengths, therefore they must be congruent. Number 3. In the diagram shown below, rectangle ABCD has been reflected across the line x equals 1. Okay, so I'm going to draw x equals 1 in blue so we can see it. X equals 1 is this line right there. Okay. Right there. Right there. X equals 1. Okay, so it's been reflected about that line. So what we're doing is we're taking the image. I'm going to put the image in red. So for this image here, what we've done is we've taken that image and we've reflected it about that blue line, which would put it, boom, right over here. Okay, now, once we get that reflection, what do we do to get the top image above, A double prime, B double prime, C double prime, D double prime? We would have to move that 1, 2, 3, 4, 5, 6, 7, 8, 9 units upward and 2 units to the left. So after reflecting about the line x equals 1, the rectangle would be translated 9 units upward and 2 units to the left. Number 4. Segment CD has endpoints C, -2, -4, and D, 4, 10. If CD is translated 5 units to the right and 2 units up, which the following is the slope of this line right here? Okay, so before we get to slope of that, first of all, we have the slope of that line, so CD, and it's going to be moved to the right and up. So what I'm going to do is I'm going to add 5 to I guess either of those points. Okay, so C prime would be C2 plus 5. So I'm basically going to add 5 because it's 5 to the right. So I'm going to add 5 to both x coordinates, and I'm at 3, and D prime, I'm at what, 9? Okay, and then here I have to go 2 units up, so I'm going to also plus 2 here. So -4 plus 2 would be -2, and then plus 2 would be 12. So what I'm going to do is I'm just going to I'm going to find the slope between these two. So the slope, so let's say I choose this point right here as my original point. Well, if we think about what we did, we went 5 units to the right. So 5 units more, okay, then, let me see here. Yeah, we can, 4, 10, 2, 4 minus 2. Okay, so yeah, I'm gonna go ahead and find my slope. Whoops, sorry. Erase a little bit here. So x1, y1, x2, y2. There we go. Okay. So my slope, y2 minus y1, so 10 minus a minus 4, and x2 minus x1, 4 minus a minus 2 would be, again, we add, so that would be 14 over 6, which would reduce to, if I divide both sides by 2, 7 over 3. So here's the deal. If you move this line anywhere, it's going to have different endpoints, but it's going to have the same slope. So the slope of the original line connecting those endpoints is the slope of any line that you translate anywhere. 7/3. All right, number 5. Describe a sequence of 2 transformations, first a translation, then a reflection, that would map triangle ABC onto triangle MNP. There are many correct answers. Be specific as possible with both transformations. Okay, so I'm going to kind of highlight in blue triangle M, or triangle A, B, and C, and we're going to talk about how we can move that to map it on top of MNP. So one way I see we could do it is we could move this triangle 1, 2, 3, 4, 5, 6, 7, 8 times to the left. So translation, 8 units left. Then what I could do is I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units down. 8 units left, 10 units down. Then, if I reflect about the line right here, y equals -2, you'll get this triangle right here. Number 6, if segment MN has the endpoints -3, 2, so that would be right here, there's M, and N has 1, 6, that would be right here, there's N. I'm going to go ahead and connect them with a line, make a line segment. Now, if MN is reflected about the point, about this line here, so I'm going to draw the line y equals x right there. Oops, I messed up. Right there. Okay, so it's reflected about that line, y equals x. Now, what that means is, remember, when we flip about that line, we flip the x and y axes. So that point is going to go down here. That point is going to go down here. Okay, so where specifically? Well, M has the point -3, 2. So that means M prime is going to be 2, -3. N has the point 1, 6. So N prime is going to have the point 6, 1. So just plotting those points, there's N prime, 2, -3, there's M prime. So there's the reflection. Taking this and reflecting it about that line produces that line segment right there. Okay, so there's the reflection part. But then it's translated 3 units to the right and 2 units down. So 3 units to the right, 1, 2, 3, actually. Hold on, let me put it right there. I'm going to copy this. So I'm going to go 1, 2, 3 units to the right, and then I'm going to go 2 units down. 1, 2. That would put it right here. Okay, so ultimately that's where MN ends up. Okay, so first it's translated, then it's moved 3 units to the right, 2 units down. Okay, so it wants to know, determine the coordinates of the midpoint. That's right there. Well, I think you can read right off the graph. It's 7/3 down. The coordinates of the midpoint are 7, -3. All right, now our final question, number 7. Consider a line whose equation is y equals 2x minus 3. We would like to find equation of translating it 4 units to the left and 5 units up. What is the new slope of the line and why? Well, the slope of this line is 2. The slope of this new line is also 2. Translated lines have the same slope. They're just moved around a little bit, that's all. Slope's gonna be the same. Okay, now the y-intercept of the original line was 0, -3. What is the image point under this translation? So what does it become? So we were at 0, -3. Okay, you think about what we did. We went translated it 4 units to the left and then 5 units up. So 4 units to the left of that would be -4, and 5 units up would be 5 more than -3 or +2. All right, so using our point from part B right here and the slope from part A right here, write the equation of the line using point-slope form. Now, if you don't remember point-slope form, let me write it. It's y equals y1. There's y1 equals, sorry, I miswrote it. Y minus y1, okay, again, y1 is right here, equals m times x minus x1. x1 is right here. So plugging into that, we have y minus 2 equals m, our slope, which is 2, times x minus x1, which is a -4. All right, so what we have here is y minus 2 equals 2, minus minus is a plus, x plus 4. Okay, I'm going to distribute through parentheses. All right, and I get y minus 2 equals 2x plus 8. Okay, and then just continuing that over to part D, add 2 to both sides, so y minus 2 equals 2x plus 8. If I add 2 to both sides, I get y equals 2x plus 10. Y-intercept is 10. Oopsie. Sorry about that. Okay, our new equation intersects, basically it intersects, it did intersect at -3. So if you think about what you did, you moved it 4 units left, 5 units up, okay? That's going to translate it up to a y-intercept of -10. All right, well, that concludes our final video tutorial for Summer School Math Course, Integrated Math Course 1A. I hope you found these video tutorials to be helpful, to be able to see them and process the work at your speed, at your time. And I wish you luck in the future math classes that you take. Thank you.